Hi, and welcome to this section of the Pre-Algebra Tutor. And in this section, we're going to study the topic of what we call factors and multiples. Now, let me tell you right now, there are a lot of topics in pre-algebra that sort of seem disconnected from one another, First, we learn how to add, subtract integers, then we learn how to work with exponents and order of operations, and they might seem like disconnected topics, just like this one on factors and multiples might seem like to be a disconnected topic. But what you're going to find is that they're like a string of beads on a string, and you must learn one before you learn the next one, and before you know it, you'll have a bag of skills so that when you get down the road a little bit to expressions and equations and some of these things that we're going to be doing a little bit later, all of these topics are going to be necessary. So you may not quite see the point of understanding these little individual topics that we have now, but once we get to some of the topics later on, you'll understand why it's so important. In this particular case, factors and multiples, factoring is a huge part of algebra and pre-algebra, and you'll see why when we start dealing with expressions. And multiples are very important also, especially when we start talking about fractions and simplifying fractions in pre-algebra. So with that, let's talk about factors and multiples. The good news is these two topics are very, very simple. They just have funny names that you might not know at first, but we're going to break through that right now. A factor is the following. Let's go ahead and write it down word by word, and then we're going to use a lot of examples to show you that it's really not that big of a deal. So what we're going to say is we're going to say the factors, this is a sort of a definition that you'll need to remember, so I'm going to underline it. The factors of a number, and I'm writing it all in terms of numbers here because you have some experience with numbers, you understand numbers, but everything we're writing is going to apply to algebraic expressions. In other words, things that have letters in them, A and B and X and Y and things like that. These are all going to apply. The factors of a number, or an algebraic expression later on, are, when we're talking about numbers, are the whole numbers that we can multiply together to get that number. All right, now you might look at this and say, well, that sure does look like a complicated definition. It looks like a lot of words here. But really, it's a very, very simple idea. Basically, what we have for a factor, when you're talking about the factors of something, we'll take a quick example. The number 10 you've dealt with all your life. You have 10 fingers, you have 10 toes, right? But we know that for the number 10, we can say that 1 times 10 is equal to 10. That's a true statement. We know that that's true. And we can also say that 2 times 5 is equal to 10. So these are all whole numbers that can be multiplied together. 1 times 10, 2 times 5. And they can be multiplied together to give you 10. So what we've learned from this is the factors, which is the word we're trying to learn here, of the number 10 are 1, 2, 5, and 10. That's it. So if on a test you were asked, what are the factors of the number 10, or what are the factors of the number 12, or whatever it is you're talking about, then really what you're trying to do is find out what numbers exist, whole numbers, no decimal points anywhere, whole numbers, so that you can end up multiplying them together to give you 10. So you notice the number 3 is not on the list. The number 4 is not on this list. And that's because the number 3, for instance, you can't multiply 3 times anything to give you 10. You can't multiply 8 times anything to give you 10. You can't multiply, 4 times anything to give you 10. So they're not factors of 10. When you say something is a factor of 10, it means that that number can be multiplied by something to give you 10. That's basically what it is. The numbers in this list can all be multiplied by something. 1 can be multiplied by 10 to give you 10. 2 can be multiplied by 5 to give you 10. 5 can be multiplied by 2 to give you 10. 10 can be multiplied by 1 to give you 10. But there are no other whole numbers that you can multiply by something to give you 10. Let's pick another example. Something that would have a few more factors. The number 18. Nice, simple number. You've you should be too scared of that. Well, let's start talking about what times what can equal 18. Well, we know that 1 times 18 can equal 18, right? We know that 3 times 6 can equal 18. And we know that 2 times 9 can equal 18. So we have a lot of numbers that can be multiplied together to equal 18. So the factors of the number 18 are, you might guess, 1, 2, 3, 6, 9, and 18. 1, 2, 3, 6, 9, 18. Now I'm putting them in any, I'm trying to put them in ascending order, but it really doesn't matter the order that you list them. These are just numbers, could be listed in any order that you want, such that every number in this list can be multiplied by something else to give you 18, you know? I mean, we already proved it up here, but 3 can be multiplied by 6 to give you 18. 9 can be multiplied by 2 to give you 18. 18 can be multiplied by 1 to give you 18. That really is all there is to understanding the concept of a factor. It's just a list of numbers, and when we get to algebra later on in the actual letters and variables, we'll learn to expand this definition just a little bit, but it's going to be exactly the same idea. Basically, it's the stuff that you can multiply by something else to give you 18. Now, let me just point one thing out to you, that I keep saying it over and over, that everything in this list of factors can be multiplied by something else to give you 18, which is true. But that's just another way of saying, it's another way of saying that all of the factors of the number 18 are basically, can be divided into 18 evenly. In other words, 18 is divisible evenly by all of these numbers. 10 is divisible evenly by all of these numbers. So that's sort of just another way to rewrite the definition of what a factor is. A factor is a number that is evenly divisible into whatever number it is you're after. So if you're looking for the factors of the number 10, then all of these numbers that you list should be evenly divisible in. And that's exactly because what we said before, they have to be able to be multiplied by something else to give you that number. So let me write that down, just so you'll have it fresh. So another way to say this, just to kind of summarize the definition that we have above, is that all factors, and factors are the list of numbers that we get here in the end, of a number, all factors of a number can be evenly divided into that number. And just to be absolutely clear, I'm going to put with no, this means with no remainder. And no remainder just means that there's nothing left over, so it divides evenly. So you might look at this and say it a different way. What are the factors of 18? Well, all you need to do is pick numbers that can be divided into 18. 18 can be divisible by 2 with no remainder. 18 can be divisible by 9 with no remainder. 18 can be divisible by 6 with no remainder. It's exactly the same definition. There's nothing different here. We're just saying it in a different way. And so just to absolutely, hone it home, we'll just go ahead and say, going back up to our previous example with the number 10, for instance, 4 isn't a factor. And why is 4 not a factor? 4 is not a factor because 4 is not, cannot be divided into 10 evenly. In other words, 4 can't be multiplied by anything to give you 10. It's the same way of saying that. 6 is not a factor. Same thing. 6 cannot be divided into 10 evenly. It can be divided into 12 evenly. It cannot be divided into 10 evenly. So if you go down to 18, 7 is not a factor. Because 7 cannot be divided into 18. You can divide 7 into 14, but you can't divide it into 18 evenly. 5 is not a factor because you can't divide it in there. So it's really saying the same thing. I'm just giving you a couple of quick examples. Factors are really, really important. You look at this and you say, well, he's teaching me this stuff about factors and numbers, not really that big of a deal. But trust me here, factoring, extremely important. I'm teaching it here in terms of numbers. But in a few sections, we're going to start talking about algebraic expressions, which are just have numbers and letters in them. And frequently you're going to have to factor an expression, which just means doing what we're doing here, but it's going to be a little different because we're going to have some letters involved. But the principle will be the same. See, knowing that a factor can be divided evenly into the number and that's a definition, extremely important. So remember that. We're going to do some more problems here in a minute. Now I want to switch gears to the other topic in this section called multiples. Multiples are very, very important also. A lot of times dealing with fractions, finding common denominators, things like that. Well, let me ask you one thing. What do you think of when I tell you something's a multiple of something? What is a multiple of 2, for instance? A multiple of 2 would be 4, or a multiple of 2 could be 6. In other words, it's when you take the number that you're looking at and you multiply it by a whole number. So let's go ahead and write a definition and show you what I'm talking about rather than talk about it. The definition, a multiple of a number is when you multiply, and I'm putting multiply in quotes because it's called a multiple. The reason it's called a multiple is because you multiply. That's why it's named that. When you multiply this number by any whole number. In other words, another way to say this is you count by that number. So let me write that down. You'll understand why in a second. I'm going to put in quotations here. You count by that number. All of you learned a long time ago, how do you count by 2s? 2, 4, 6, 8, 10, 12, 14, 16, right? You're doing multiples. That's what multiples are, is when you start counting by the number, the base number that you have. How do you count by 3s? 3, 6, 9, 12, 15. You're basically adding one more multiple each time you get the different number. How do you count by 4s? 4, 8, 12, and you go on and on and on. You keep adding on that number. How do you count by 5s? 5, 10, 15, 20. Each time you get a new multiple, you're just adding 5 more. That's all a multiple is, because each time you're multiplying it by a whole number. Let me show you exactly what I'm talking about here with something that you understand. So, the number 2. If you want to find the multiples of the number 2, then, well, let's just talk about it. Let's count by 2s. Let's find the multiples. The multiples are equal to counting by 2s. So let's start at 0. You always start at 0. 0, 2, 4, 6, 8, 10, 12. So you already know how to count by 2s. You just didn't really know that it was called multiples necessarily. Why is it called multiples? Because the first number in this list is 2 times 0. The second number in this list is 2 times 1. The third number in the list is 2 times 2. 2 times 3. 2 times 4. 2 times 5. 2 times 6. So what am I doing here, you might say? Well, here, the base number that I'm counting by, or that I'm trying to find the multiple of, is the first number here. It's always 2. But each time I find the next number in the sequence, I'm just multiplying it by a whole number. So here I'm multiplying by 0, here I'm multiplying by 1, here I'm multiplying by 2, I'm multiplying by 3, I'm multiplying by 4, I'm multiplying by 5, I'm multiplying by 6. Multiply, multiply, multiply. That is why you're getting multiples. So sometimes people confuse factor and multiple because they're taught generally at the same time. Multiple, you need to think of multiplication, okay? Getting a list of numbers, they get bigger and bigger and bigger because each time you're just multiplying the base number by a bigger and bigger number, 2, 3, 4, 5, 6. So you can get a large, infinitely large set of multiples, whereas factoring is completely different. You're going to get a single list of numbers that are factors of a number, but when you get the multiples, you can go on and on and on getting as many multiples as you want, because all you're doing is taking the base number and getting more and more numbers in the sequence by multiplying by a whole number. So that's what the definition means. A multiple of a number, this number, is when you multiply this number, this guy, by any whole number. It's kind of a hard to read definition, but basically you take the base number, You multiply it by something, and then you're getting a new multiple. So that's basically what it is. Now what we're going to do is we're going to work several problems so that you can get comfortable with this, because just like anything else in all of math, if you work enough problems, understand the relationships, and start to see what's going on, you'll get really good at it. All right, so let's go ahead and do problem number 1. Let's go ahead and find the factors. So I'm going to write the word factor. The factors of the number 9. Let's say, how do you find the factors of the number 9? Well, there's a lot of different ways to do it, but in the beginning here, probably the easiest way to do it is just try to figure out what numbers can be multiplied together to give you a 9. Well, right off the bat, you've got 1 times 9 is equal to 9. And you've also got 3 times 3 is equal to 9. So I don't believe there's any other numbers you can multiply together to give you a 9. Yeah, you could say, here you have 1 times 9. You could flip it around and say 9 times 1, but in the end, it's going to give you the same answer. So the factors that we get are going to be these numbers, 1, 3, and 9. These are the factors of this number. In other words, another way to look at this is these are the only 3 numbers that can be divided into 9 evenly with nothing left over. If you pick another number, 4, 9 divided by 4 doesn't go evenly. Pick another number, 6. 9 divided by 6 doesn't go evenly. So you can do this either way you want. You can try to list everything that can multiply together, or you can just go in your head and start thinking of numbers and see if they divide evenly into your parent number. And if they do, you write them down. All right, so that's it for number 9. Let's look at the number 8. What can be multiplied together to give you 8? Well, you always are going to have 1 times 8. You're going to have 2 times 4. These are both going to be 8, right? And that's about it. I don't think there's anything else that can really do that, that can really be multiplied together to give you 8. Again, you can flip it around and say 4 times 2, but that's not really going to help you. So the factors in this case are 1, 2, 4, and 8. 1, 2, 4, and 8. Again, if you flipped one of these around to say 8 times 1, you would end up listing those numbers as being factors, and so they wouldn't really add to your list. So there's no reason to start listing, 4 times 2 and 8 times 1, because they're going to give you the same exact numbers. So there's really no reason to start flipping things around. You're just trying to find unique numbers. Next number, 7. What can be multiplied together to give you 7? Well, I think there's only one number, or 2 numbers here, that can be multiplied together to give you 7, and that's it, 1 and 7. There's nothing else. So the factors are 1 and 7. Those are the 2 numbers that can be divided evenly into the number 7. What else? Number 4. Let's look at the number 6. What can be multiplied together to give you 6? Well, you have 1 times 6 is equal to 6, and you have 3 times 2 is equal to 6. But there's nothing else. I mean, you could do 2 times 3, but that's not going to really add to your answer. So the factors are 1, 2, 3, and 6. 1, 2, 3, and 6. It's a pretty bulletproof process once you get into it. 3. What about number 3? What can be multiplied together to give you 3? Well, you have 1 times 3 is equal to 3, but there's nothing else. I mean, you can't take anything else and multiply it together to give you 3. So the factors are 1 and 3, and that's it. Let's do something interesting. They might try to trick you in the book and say, well, what about the number 1? What are the factors in number 1? But just take it one step at a time. You realize the only thing you can multiply together to give you 1 is 1. 1 times 1 is 1. So the only factors you have is the number 1. The number 1 is the only number that can be divided into number 1 to give you the answer. So not really a trick question. It's just different. What about 15? Well, you have 1 times 15. You have 3 times 5 is equal to 15. Again, you have 5 times 3, but those are the same numbers. That's not going to help you. So the only factors you have is 1, 3, 5, 15. 1, 3, 5, and 15. All right, let's do another one on this board, and then we'll switch over to the other board. Let's say we have the number 20. Now we start getting into larger numbers. When you get into larger and larger numbers, you're going to have more factors. So let's see, 1 times 20 is equal to 20. We have 4 times 5 is equal to 20. And you have 5 times 4 also, but that's not really going to help you. You also have 2 times 10 is equal to 20. But I don't think there's anything else that you're really going to have. You know, again, you have 10 times 2 and 5 times 4, but those aren't really going to contribute. So the only factors you really have are 1, 2, 4, 5, 10, and 20. 1, 2, 4, 5, 10, and 20, and that's it. And when you think about it, another way to do this problem, if you didn't want to list all of this out, is you could just start with this number and start going through your numbers and see what is divisible that can go evenly in. Well, 1 can go evenly in, 2 can go evenly in, 4 can go evenly in, and so on and so on. But for instance, 8 cannot go evenly in. There's nothing you can't divide 8 into 20 and get anything even. You're going to get a remainder, and so that's the problem. That's what you don't want. Let's do one more and just kind of broaden it a little bit, make it a little bit difficult for our last one. The number 48. Pretty large number. Now I'm going to tell you right now, if you start trying to go through and multiply everything together that can give you 48, there's a chance that you can miss something. So just do your best and take it one step at a time. 1 times 48 is equal to 48. What else? 2 can be divided in here, and it can go 2 times 24 is also equal to 48. What about the number 3? At first, you might not think the number 3 can go into this, but when you think about it, 3 times 16, if you get a pencil and paper out, you'll figure out that that's also equal to 48. 4 can go in. 4 times 12 is 48. That's just from straight up your multiplication tables. And then 5 can't go in, but 6 can go in. 6 times 8 is 48. All right. Now, again, you can flip these around and say 12 times 4, right? Or 8 times 6 or 16 times 3, but those aren't really going to give you any additional numbers for your factors. So the factors of this guy are 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. And again, you need to be careful when you start getting into larger numbers because it's easy to miss one of these combinations. You just do the best you can and start marching up and make sure that you have everything there. And so these numbers, every one of them can be divided evenly into this guy, and that's what we call a factor. Now, before we go on and do a couple of problems with multiples, I want to show you something, sort of a preview. What if I asked you, we're going to do a lot of these kinds of problems later, but what if, instead of a number, what if I said you had some expression like A times B times C? Now, these are letters. Don't worry about the fact that they're letters because all of these letters in algebra, they're just numbers that you don't know the value of. So I don't know what A is equal to. Is A equal to 2 or is A equal to 5? I don't know. So I just put A down. But A, whatever it is multiplied by B, whatever that is multiplied by C, whatever that is. But they're all going to be numbers in the end. I just don't know what they are. So what are the factors of this expression? What are the factors? Factors just mean what can be multiplied together to give you A, B, C. And the answer is just sort of like staring you at the face, A, comma, B, comma, C, because these things are the only things that can be multiplied together to give you A, B, and C. Another way to look into it, another way to look at it, it's a little bit harder to see here, but it makes sense with the numbers. These guys, A, B, and C, can divide evenly into this guy, and we'll talk about why later, but sort of the easiest way to look at it is the definition of a factor, just like 8 times 6 is 48, so 8 and 6 are both factors. A is multiplied by B is multiplied by C, so by definition all of them have to be factors because they're all able to be multiplied together to give you the final answer. One more really quickly. What about A squared times C? Now we've talked about exponents before in the previous section, so you should know that when you see A squared C, that's just A times C. And I can put my dots in there, that's fine, but I can leave it just like that. This is what the exponent means. A squared is A times A. So when I'm going to write the factors down, I just look and see, well, what's multiplied together to give me what I have? Well, A is multiplied in there and C is multiplied in there. So those are both factors. These are both factors of this original, what we call an expression. But I guess I'm just giving you a little bit of a preview. So far we've dealt with numbers. I think you're pretty comfortable with making the factors of the numbers. So I'm trying to show you that this stuff is no different than the numbers. With the numbers, we just try to find numbers that can multiply together to give us whatever number we're after, and those are the factors. Here is the algebraic expression. These things are the things that can be multiplied together to give me this. These things are the things that can be multiplied together to give me this. So these are the factors. So later on, when we get into more complicated expressions, you'll understand that it's not such a mystical thing because it's the same thing apply to numbers. All right, so what I want to do now is erase the board, and we'll do a couple of problems on multiples. Okay, let's go ahead and do our problems on multiples. They're not going to be very difficult, but you need to prove to yourself that you understand what they are. So what we want to do is we want to write the first 5 multiples of the number given. And so for our first number, we're going to have the number 2. So my question to you is, what are the first 5 multiples? Basically, the easiest way to do multiples, especially if you're doing the first 5, is just count by that number. That's probably the easiest thing to do. So if you're counting by 2s, and you always have to start at 0, you're going to have 0, 2, 4, 6, 8. Now stop, because this is the first 5 multiples. This is the first, second, third, fourth, and fifth. And to just absolutely drill it home, this is 2 times 0, this is 2 times 1, this is 2 times 2, this is 2 times 3, and this is 2 times 4. So this is the, the 5 multiples, because you're just basically taking your base number and multiplying it by a number, so you're getting a multiple. Now let's say you wanted to find the first 5 multiples of the number 3. Well, it's the same thing. You count by 3. So 0, 3, 6, 9, and 12. And that's it. That's the first 5. So you can stop there. And just to absolutely make sure you understand, this is 3 times 0. This is 3 times 1. This is 3 times 2. This is 3 times 3. This is 3 times 4. So each time we're just incrementing and we're multiplying by one more, and so we get the multiples there. Each time we're multiplying by a bigger number, so we get it. What about multiples of 4? Well, we start with 0. We count by 4s. 4. 4 plus 4 gives us 8. 8 plus 4 gives us 12. 12 plus 4 gives us 16. Each time we just add 4 more. So this is 4 multiplied by 0, 4 times 1, 4 times 2, 4 times 3, 4 times 4. Okay? What about multiples of 5? 0, 5, 10, 15, 20. 5 times 0, 5 times 1, 5 times 2, 5 times 3, 5 times 4 is 20. What about multiples of 6? You've got 6 times 0 gives us 0. 6 times 1 is 6. 6 times 2 is 12. 6 times 3 is 18. 6 times 4 is 24. So you have 0, 6, 12, 18, 24. You're just multiplying by numbers. What about 9? Start with 0. 9 times 0 is 0. 9 times 1 is 9. 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. So you're counting by 9s. And the final one we'll do is an easy one, because we always know how to count by 10s. We start at 0. 10, 20, 30, and 40. So what we have is 10 times 0, 10 times 1, 10 times 2, 10 times 3, 10 times 4. And that is really all it amounts to when you're dealing with multiples. Multiples are going to be useful later on for lots of things, but especially when we start doing fractions and common denominators, and we're doing that with algebra and stuff, we're going to refer to the multiples of an expression or the multiples of a number. And later on, when we're simplifying expressions and solving equations, it's going to be very frequent that you'll factor the expression, or you'll factor the equation. And you'll need to know that what that means is you're looking for something that can divide into that, because that's what a factor is. And that's what we're going to be talking about next. I'm Jason. I hope you've learned something from this section. Not difficult topics, especially when we talk about numbers. Later on, we'll get into their application with equations and expressions. And I hope that you'll see that it's just an extension of this. And if you understand this, then along with the other topics we'll have, you'll get a great foundation and eliminate some of the uncertainty and fear that comes along with pre-algebra, and hopefully you'll see that it's not such a big deal.